Hello students, welcome to CT class. I hope everyone doing good. Okay, so in today's class, we'll be having the discussion on current electricity. So what is current electricity? It deals with the study of charges in motion. As you all know that in this particular part, so first we'll be studying about the definition of current. So everyone know the definition? The flow of charges in a unit time. Flow of charges in a unit time is nothing but current. So the formula for the current is I is equal to Q by T. I is equal to Q by T. Right. The SI unit of current is ampere. So you all know that the current can also be written in terms of N, that is number of electrons. So I is equal to Ne by T, where E is the charge of an electron. You know the value of that? It is 1.6 into 10 to the power minus 19 coulomb. Okay. The thing basically, like here what we are going to deal is, so based on the current density, the next is the current density. So current density is defined as current per unit area of cross section of the conductor. Current per unit area of the cross section of the conductor. It is denoted as J. So J is equal to I by A. Okay. The SI unit of current density is ampere per meter square. Ampere per meter square is the SI unit of current density. Okay. The next is drift velocity. What do you mean by drift velocity? It's the average velocity. It is the average velocity acquired by free electrons. Acquired by free electrons inside a metal by the application of an electric field which is responsible for the current through it. So current through it and responsible for the within the metal, all this is going to be taken. There will be an average velocity is going to be traveling. Okay, so the drift velocity is quite you know that you have the expression also for the drift velocity. It is Vd is equal to I divided by NEA. I divided by NEA. Before that, you should also know that I, the current. So current is equal to NEAVD. That is the current. So based on that also we can define. Now, when you see the direction of the drift velocity for the electron in a metal is opposite to that of the electric field. So in electric field apply ಮಾಡ್ತೇವೆ ಅದಕ್ಕೆ always ಏನಾಗಿರುತ್ತೆ drift velocity will be moving in opposite. Okay, so greater the electric field, larger will the drift velocity. The reason is drift velocity is directly proportional to the electric field. Next, when a steady current flows through a conductor of non-uniform cross section, so if you don't have the uniform of cross section, linear, and there will be different variation ಇತ್ತಂದ್ರೆ, then it is area of cross section is inversely proportional to the drift velocity. You know that where the area is more, where the area is more, the drift velocity will be less. Where the area is less, the drift velocity will be more. Hmm. I hope you are clear with that. So from this I can say if the area is less than, from according to this diagram, If the area of one side is less than the other side, then the drift velocity will be opposite. Okay. Next, if the diameter is been doubled, then the drift velocity of the electrons inside it will not change. Okay, you have to remember that. Next, Ohm's law. So as you all know that at constant temperature, current flowing through the conductor at constant temperature, current flowing through the conductor is directly proportional to the potential difference across its ends. Okay, so if I want to write it in mathematically, I can write it as V is equal to I into R, where I is nothing but current, R is the proportionality constant called resistance. It is a proportionality constant called resistance. Okay, and the one thing you have to understand, Ohm's law is not universal law. Since you have two types of devices, one is ohmic devices and non-ohmic devices. Ohmic devices, it obeys the Ohm's law. Non-ohmic devices, which does not obey the Ohm's law. Okay, in that case, you cannot say the Ohm's law is universe. Okay, so the example for ohmic devices is all the metals. Non-ohmic devices, diode, resistors, sorry, diode, transistors. Okay, all these are the non-ohmic devices. And here the graph what we have given here, we have two different temperatures. That's been here it is like only one. So the thing you have to remember, one resistance is equal to 1 by slope. Resistance is equal to 1 by slope. So based on the slope, you can decide whether the temperature is greater or lesser, that you can understand. Okay. Okay, the next is resistance. What is resistance? It is the opposition to the flow of current. It is the opposition to the flow of current. So resistance can be written in terms of voltage and current. It can also be written in terms of resistivity, length and area. As you all know that the resistance is going to be dependent on length. It is how it is going to be dependent. It is directly proportional. Directly proportional. Area of cross section, again it is going to depend on area of cross section, but it is inversely proportional. Okay, so it is going to depend on length, area of cross section and resistivity, that is nothing but rho, and finally it can also be depend on temperature. Okay, the unit of resistance is ohm. Okay, so next, if you see, resistance is going to be depend on temperature. From that particular case, you can say temperature coefficient of resistance. Temperature coefficient of resistance. So here you can see the formula. If you have the temperature is greater than 300 degrees Celsius, then you are going to use this formula. RT is equal to R naught 1 plus alpha t plus beta t square if t is greater than 300. Okay, if t is less than or equal to 300, then the formula will be RT is equal to R naught plus R naught into 1 plus alpha t. So this is very important formula. So where alpha is nothing but temperature coefficient, that can be written as alpha is equal to RT minus R naught divided by R naught into T. Okay, if you have two temperatures for different resistors, different temperatures, then the formula will be R1 by R2 is equal to 1 plus alpha T1 divided by 1 plus alpha T2. This is one form. The another form you can see next, the value of alpha is different for different temperature. Okay, so on an averagely you can calculate as alpha is equal to R2 minus R1 divided by R1 into T2 minus T1 divided by. That is the formula you have to remember. Next is resistivity. As you all know that resistivity is nothing but it is going to be based on the nature of the material. Okay, so SI unit of resistivity is ohm meter. The formula will be rho is equal to RA by L. That's the general formula. So in terms of relaxation time, you have already studied about relaxation time. So the time taken for colliding an electron from one point to the another point, that is nothing but your um relaxation time. So if I want to represent the resistivity in terms of relaxation time, so rho is equal to m divided by n e square into tau. That will be very important. Okay, next they've given for different substances the resistivity is also different. So for silver it is minimum. So from that you can say silver is the best conductor of electricity. So conductivity is nothing but the reciprocal of resistivity. Okay, conductance is the reciprocal of resistance. I hope you are clear with that. Okay, the next is very important, stretching of the wire. So normally you will be seeing the numericals based on the stretching of the wire. Okay, if a conducting wire stretches means it is going to be increase. If you start pulling that wire, stretch ಆದಾಗ its length increases, area of cross section decreases, so resistance increases. So length increase ಆಯ್ತು ಅಂದ್ರೆ resistance increase ಆಗುತ್ತೆ. Area of cross section decrease ಆಯ್ತು ಅಂದ್ರೆ resistance increases. But the one thing you have to remember is volume remain constant. You have to remember that volume remain constant. You can see the diagram here before stretching, after stretching. So before stretching, you can see that particular area of cross section. After stretching, the area of cross section decreases. So please remember, whenever you start stretching the wire, the length and the area changes, but the volume does not change. So please remember that. That's very important. Next, color code. So as you know that, what is the purpose of using the color code? Since you can see at the picture I've given here, the resistors what you are going to see, it's very small. Since it is very small, if I print the values on that, you cannot able to read it. You cannot able to read it. So that is the purpose we are going to see the color code. So you can see this is the resistor. So you have band A, band B, band C and band D. So you have four bands here. The first two bands tells about the numbers. Third band tells about 10 to the power. Okay, 10 to the power 0, 10 to the power 1, 10 to the power 2, 10 to the power 3. Okay, so based on that, the fourth band is nothing but you are going to talk about the tolerance. So for in the case of the fourth band, we'll be having the three colors. One is gold, silver, and no color. They won't be indicating any of the color there. So in that case, for gold, it is plus or minus 5%. For silver, it is plus or minus 10%. For no color, it is 20%. Okay, you can see here the table we have given. So the first one, black, brown, red, orange, yellow, green, blue, violet, gray, white. Okay, the value starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then again 10 to the power 0, 10 to the power 1, 10 to the power 2, 10 to the power 3, 10 to the power 4, up to 10 to the power 9. Suppose instead of fourth band, if the gold and silver is being present in the third band, then the power will be 10 to the power minus 1 for gold. For silver, it is 10 to the power minus 2. That we have to remember. See, if I want to remember the sequence of the color code, I have to remember this sentence. B.B. Roy of Great Britain had very good wife wearing gold silver necklace. B.B. Roy of Great Britain had very good wife wearing gold silver necklace. Here you can see the block letters what we have presented here. All that will be, you have to remember all that block letters you have to remember in the colors format. Okay, I hope you are clear with that. The next is grouping of resistors. What is the purpose of this grouping of resistors? To get the desired value. So ನನಗೆ ಯಾವ ವ್ಯಾಲ್ಯೂಸ್ ಬೇಕೋ ಯಾವ ಥರ ಪರ್ಟಿಕ್ಯುಲರ್ ವ್ಯಾಲ್ಯೂಸ್ ಬೇಕೋ ಬೇಸ್ಡ್ ಆನ್ ದ್ಯಾಟ್ ನಾನೇನು ಮಾಡ್ತೀನಿ ಈ ಗ್ರೂಪಿಂಗ್ ಆಫ್ ರೆಸಿಸ್ಟರ್ಸ್ ಮಾಡ್ತೀನಿ whether it may be in series or it may be in parallel. Okay, if I want to get the higher values, I have to connect that resistors in series. If I want to get the resistance value very lower, then I have to connect that in parallel. Okay, right. In series combination, you have to remember current will, suppose if you have the resistors connected 3, 2 or 4, so how many ever the resistors has been connected in series, the current passing through that circuit will be same. Current passing through that circuit will be same. That you have to remember. But what about the voltage? So voltage will be different at each and every resistors. Current will be same, but voltage will be different. And we have already studied about the derivation part in your theory. So Rs is equal to R1 plus R2 plus R3. Here it is 3 resistors. They may give 2 or they may give 4. Okay, so that you have to remember. If you have n identical resistors ಅಂದ್ರೆ ಒಂದೇ ತರ resistors ಅಂದ್ರೆ ಸೇಮ್ ವ್ಯಾಲ್ಯೂ ಇರೋ resistors ಸೀರೀಸ್ ಅಲ್ಲಿ ಕನೆಕ್ಟ್ ಆಗಿತ್ತು ಅಂದ್ರೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಯು ಹ್ಯಾವ್ ದ ಫಾರ್ಮುಲಾ ಆರ್ ಈಕ್ವಲೆಂಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎನ್ ಆರ್ ಅಂತ ಹೇಳ್ತೀವಿ. ವಾಟ್ ಈಸ್ ಯುವರ್ ಎನ್? ನಂಬರ್ ಆಫ್ resistors. R is the value of that particular resistor. Then the potential difference also can be written as V by N. Okay. Next, grouping of resistors in parallel. In this particular case, you are going to see all the resistors will be connected in parallel. Then it is going to be connected to a battery. Here, the voltage, that is nothing but potential difference, is going to remain constant. And there is no change in the potential difference, but current is different for different resistors. Each and every resistors ಗೆ current vary ಆಗ್ತಾ ಹೋಗುತ್ತೆ, but the voltage is going to remain constant. Okay, so if that is connected in parallel, then the equivalent resistance will be 1 by R P is equal to 1 by R1 plus 1 by R2 plus 1 by R3. And in general ಆಗಿ R1 R2 R3 divided by R1 plus R2 R1 into R2 plus R2 into R3 plus R2 into R1. ಯಾವ್ದು ಬಂದು ನಾವೇನು ಮಾಡ್ಬೋದು, ಅದರಲ್ಲೇ ಡೈರೆಕ್ಟಾಗಿ ಎಲ್ ಸಿ ಎಮ್ ತೊಗೊಂಡು ಸಾಲ್ವ್ ಮಾಡಿ ಫೈನಲ್ ಆಗಿ ರೆಸಿಪ್ರೋಕಲ್ ಮಾಡಿ. ಓಕೆ, ಸೊ ಟೂ ರೆಸಿಸ್ಟರ್ಸ್ ಇತ್ತು ಅಂದರೆ, ಸೊ ದ ಈಕ್ವಲೆಂಟ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇಸ್ ಸ್ಮಾಲರ್ ದ್ಯಾನ್ ದ ಮಿನಿಮಮ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ದ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇನ್ ದ ಕಾಂಬಿನೇಷನ್. ಅದನ್ನು ತಲೆಯಲ್ಲಿ ಇಟ್ಕೊಳ್ಳಿ. ಈಗ ಎರಡು ರೆಸಿಸ್ಟರ್ಸ್ ಪ್ಯಾರಲಲ್ ಇರ್ತಂದರೆ ಡೈರೆಕ್ಟಾಗಿ ಬರಿಬೋದು R1 R2 ಡಿವೈಡೆಡ್ ಬೈ R1 ಪ್ಲಸ್ R2. ಓಕೆ, ನೆಕ್ಸ್ಟು ಕರೆಂಟ್ ಥ್ರೂ ಎನಿ ರೆಸಿಸ್ಟೆನ್ಸ್ ಅಂದರೆ ಇಲ್ಲಿ ಬ್ರಾಂಚ್ ಕರೆಂಟ್ ಅಂತ ಬರುತ್ತೆ. ಸಪೋಸ್ ಈ ಥರ ಇದೆ ಸರ್ಕ್ಯೂಟು, ನಾನು ಕರೆಂಟ್ I1 ಕಂಡುಹಿಡಿಬೇಕು ಅಂದರೆ ಫಾರ್ಮುಲಾ ಏನು ಅಂದರೆ ಮೇನ್ ಕರೆಂಟ್ ಅಂದರೆ ಟೋಟಲ್ ಕರೆಂಟ್ ಇಂಟು ಆಪೋಸಿಟ್ ಯಾವುದು. ಇವಾಗ I1 ಕಂಡುಹಿಡಿಬೇಕು, ಈ ರೆಸಿಸ್ಟರ್ಗೆ ಆಪೋಸಿಟ್ ಯಾವುದು R2. ಸೊ I ಇಂಟು R2 ಡಿವೈಡೆಡ್ ಬೈ ಟೋಟಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್. I ಇಂಟು R2 ಡಿವೈಡೆಡ್ ಬೈ ಟೋಟಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಅರ್ಥ ಆಯ್ತಾ? ದಟ್ ಈಸ್ ದ ಬ್ರಾಂಚ್ ಕರೆಂಟ್ ಅಂತ ಕರಿತೀವಿ. ಇನ್ ಐಡೆಂಟಿಕಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಅಂದರೆ ಯಾವುದು, ಎನ್ ಐಡೆಂಟಿಕಲ್ ರೆಸಿಸ್ಟರ್ಸ್ ಇತ್ತು ಅಂದರೆ ಆರ್ ಪಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಆರ್ ಡಿವೈಡೆಡ್ ಬೈ ಎನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಕರೆಂಟು ಐ ಡಿವೈಡೆಡ್ ಬೈ ಎನ್ ಆಗಿರುತ್ತೆ. I hope you are clear with the synopsis, right? Good. So now we'll see with the numericals part. Okay, so the next is multiple choice questions. We'll see the first problem. Which of the following acts as a current protection device? Which of the following acts as a current protection device? Option A, fuse. Option B, conductor. Option C, inductor. Option D, switch. So as you already studied about this in your lower classes also, fuse is going to act as a circuit protection device. You know that fuse is an electrical safety device that protects, that operates to provide overcurrent protection, that operates to provide overcurrent overcurrent protection to an electrical circuit. That you have to remember. Okay, we'll see with the next problem. So right answer will be your option A. Okay, so next we'll see with the second one. The resistance of the wire is R ohm if it is melted and stretched to n times its original length. Its new resistance will be, okay. So as you all know that R is equal to rho L divided by A. Since there is stretching of the length, so I can say L dash is equal to Nn. L dash is equal to Nn. That is the given. As you know that if you go on stretching the wire, the volume is going to remain constant. So I can write A dash L dash is equal to A into L. So A dash is equal to AL divided by N dash. But what is your L dash? So AL divided by N into L. So LL get cancelled. So A dash is equal to A divided by N. Okay, fine. So R dash is equal to rho L dash divided by A dash. It's nothing but the new resistance. So we have to keep rho as it is. L dash is equal to NL, okay, divided by A dash is nothing but A divided by N. So when the N is being shifted to the numerator, it becomes rho L square, the rho N square L divided by A. So as you know that R dash is equal to n square rho L divided by A. But rho L divided by A is nothing but R. So it is n square R. So option B is the right answer. I hope you are clear with this. Okay. The next problem, if a wire is stretched to make it 0.1% longer, if a wire is stretched to make it 0.1% longer, its resistance will, okay, you have to understand here, after stretching the length of the conductor is going to be increased. Okay, the length of the conductor is going to be increased x%. It is going to increase by x%. Then the resistance will be increased by 2x%. Please in the napkat code, after stretching, after stretching, if the length of the conductor is going to be increased by x%, then what happens to the resistance value? It is going to be 2x%. But you have to see the one condition. It is going to be valid when x is less than 10%. If x is less than 10%, then you can apply this condition. Okay, so you can say it a point one nearer than the final answer will be it increases by 0.2%. Option B. Okay, next, a wire of resistance 4 ohm is stretched to twice its original length. The resistance of stretched wire would be, okay. So again the same thing, since the volume is going to be same, I can say the area A dash L dash is equal to AL. So A dash is equal to AL divided by L dash. But as they've given, L dash is twice its original. So I can write it as AL divided by 2L. L and L get cancelled. So A dash is equal to A by 2. Now we have the new resistance. So R dash is equal to rho L divided by rho L dash divided by A dash. So rho into 2L. You can let twice its original length divided by A by 2. So I'll write it here. So A by 2. 2 made out and it becomes 4 rho L divided by A. But R into rho L by A is nothing but R. But R value put to the resistor 4 into 4. So it is 6 ohm. 16 ohm is your new resistance value. So option B is the right answer. Okay. So I hope you are clear with that part. Done. Okay. You can see the next problem. When uniform wire of resistance R, when uniform wire of resistance R is stretched uniformly, is stretched uniformly to increase its length, to increase its length by 10%, to increase its length by 10%, then what happens to the new resistance value? Okay, so here we'll be doing one by one, stepwise. You can say that here the length has been increased. So can I write it as L dash? Okay, I will be writing that as an L dash L dash is equal to L plus L divided by 10 ಅಂತ ಬರಿಬಹುದಾ? It increases by 10% ಅಂದ್ರೆ divided by 10 only. Okay, ಈಗ LCM ತಗೊಂತೀನಿ. So LCM will be 10. So 10L plus L is 11L. That is your L dash. Okay, fine. So your area of cross section, volume will be same, right? So area of cross section under the volume will be equal. So A by A. So A dash is equal to AL divided by L dash. I hope you understand. You understood with this. Okay. So now R dash is equal to rho L dash divided by A dash. So rho into L dash is 11. Okay. L dash per the So I'll write L dash only divided by, instead of A dash I'll be writing AL divided by L dash. But L dash means so rho L dash the whole square divided by AL, that is your R dash. But R dash is equal to rho L rho by, okay, rho L by ಆ ಥರ ಇದೆ ಹೌದಾ? So rho into L dash ಅಂದ್ರೆ 11L divided by 10 the whole square whole divided by AL. So ಅದೇನಾಯ್ತು 11 into 11 is 121 L square divided by 100 into rho divided by A into L. So square ಮತ್ತೆ L cancel ಆಯ್ತು. ಆಗಿರೋ 121 divided by 100 ಅಂದ್ರೆ 1.21 1.21 into rho L by A is nothing but R. So R dash is equal to 1.21 R. So option B is the right answer. Okay, done. So if you see with the next problem, a current of 2 ampere A current of 2 ampere is passing through a metal wire. A current of 2 ampere is passing through a metal wire of cross-sectional area. So just to see the data what they are given. Okay, current they are given, then area of cross-section, then number density, that is nothing but N they are given, then they are given with the charge. So you have to find the drift velocity. You know the formula for the drift velocity is Vd is equal to I divided by NA into E. So what is your current? 2 ampere. So 2 divided by N is 5 into 10 to the power 26 into 2 into 10 to the power minus 6 into 1.6 into 10 to the power minus 19. So 1.6 into 10 to the power minus 19. Okay. So 2 divided by 26, that is 10 to the power 26, 10 to the power minus 6. That becomes 10 to the power 20. Okay. So 5 into 2 into, let's see here. If I shift the decimal, 10 to the power minus 1 ಆಗುತ್ತೆ. So 16 into 10 to the power minus 20 into 10 to the power plus 20. Okay, ಆಗ ಈ 10 to the power minus 20, 10 to the power plus 20 cancel, 2 and 2 get cancelled. So 1 divided by 16 into 5 is 80 meter per second. So option C is the right answer. You are clear, right? Okay. So the next is two identical conductors maintained at maintained at same temperature are given potential differences in the ratio 1 is to 2. Then the ratio of the drift velocity. So please remember that the drift velocity in terms of if I want to write it in terms of electric field ಬರಿಬೇಕು ಅಂದ್ರೆ formula. So formula will be Vd is equal to E tau divided by m into E. But you know that E is nothing but V by L. V by L. And a substitute ಮಾಡ್ಕೊಳ್ಳಿ. So Vd is equal to E tau divided by m V by L. So from this you can say Vd is directly proportional to voltage, right? So then it is the answer will be 1 is to 1. No, 1 is to 2 is the right answer. ಯಾಕಂದ್ರೆ directly proportional ಆಗಿರೋದ್ರಿಂದ they're given the potential difference as 1 is to 2. So the answer also will be 1 is to 2 only. Okay. Next, the problem is based on the color code. So when you see this problem, okay, they're not given in plus or minus percentage. In percentage, they are not mentioned. So to find that percentage, I'm going to divide. You know this formula, delta x divided by x into 100%. It's nothing but relative error and percentage error. First year formula ಓದಿದ್ರಿ. So 0.7 divided by 47, 0.7 divided by 47 into 100 ಮಾಡಿದ್ರೆ you will get it as how much you will get. You just check with that. So 10% ನೋಡಿ. ಕರೆಕ್ಟಾ? ಸೊ 10% ಬರುತ್ತೆ. ಓಕೆ, ಇದನ್ನ ಸಾಲ್ವ್ ಮಾಡಿದಾಗ 0.1 into 100 is nothing but 10%. ಹಾಗೆ ಇದನ್ನ ಹೇಗೆ ಬರಿಬೋದು? 47 into kilo ಅಂದರೆ 10 to the power 3 plus or minus 10%. So ಈಗ ಅನಲೈಸ್ ಮಾಡಿ 4 it is nothing but yellow, violet, 10 to the power 3 ಅಂದ್ರೆ orange. So option B, yellow, violet, orange, silver. That will be the right answer. Clear? Fine. A resistor has a color code of green, blue, brown, and silver. What is its new resistance? ಅಂತ ಕೇಳಿದ್ದಾರೆ. So you have the values. You have to remember the table. So green 5, blue 6, brown 10 to the power 1, silver plus or minus 10%. So 56 into 10 to the power 1 under 560 ohm plus or minus 10%. So option B. Okay. All right. The next, they're given I and V. They're given I and V are respectively the current and voltage. I and V are respectively, the current and voltage in the metal wire of resistance R. The IV graph of two differences, temperature T1 and T2. The one thing you have to remember, as we have already told, okay, slope slope is equal to 1 by R, or R is equal to 1 by slope. If the slope increases, resistivity decreases. Why? Because it is inversely proportional. If you see in this comparison, so the slope of T2, okay, slope of T2 is less than slope of T1. So ಇದು greater ಆಗಿರೋದ್ರಿಂದ. So, but what happens to the resistance? So T2 is greater than T1. ಹೌದಾ? R2 is greater than R1 ಅಂದ್ರೆ obviously T2 is greater than T1 ಆಗಿರುತ್ತೆ. So, but ಇಲ್ಲಿ ಆಪ್ಷನ್ಸ್ ಯಾವುದೇ ತರ ಕೊಟ್ಟಿಲ್ಲ. But can I write it as T1 is less than T2? ಆಗ ಯಾವುದು? ಆಪ್ಷನ್ ಸಿ. ಅರ್ಥ ಆಯ್ತಾ ಎಲ್ಲರಿಗೂ? ನೆಕ್ಸ್ಟ್ ನೋಡ್ಕೊಳ್ಳಿ. A silver wire has a resistance of 1.6 ohm 1.6 ohm at 25 degrees Celsius and a resistance of 2.5 ohm at 100 degrees Celsius. The temperature coefficient of resistance of silver. Here you have the formula. You have the formula to understand this. Okay. So alpha is equal to R2 minus R1 divided by R1 into T2 minus T1. Less ಮಾಡ್ತೀನಿ. R2 is 2.5 minus 1.6 divided by 1.6 into 100 minus 25.5. Okay, so 2.5 minus 1.6 is 0.9 divided by 100 minus 25.5 is 74. So 74.5 into 1.6 into 1.6 module. Okay, so it will be 0.9 divided by 119.2. So 0.9 divided by 119.2. So you'll get the answer as 0.00755. So 1, 2, 3. So 7.55 into 10 to the power minus 3. That will be our final answer. So option B. I hope you are clear with this problem. Okay. The one thing you remember, if it is in decimal, you can change that to the whole number. Then it will be quite easy to solve. Okay. Done. Okay. Next, the 12th problem. We are going to see the 12th problem. The temperature coefficient of resistance of the wire is 0.00125 per degree Celsius At 0 Kelvin, its resistance is 1 ohm. Now, if the resistance is 2 ohm, what will be the temperature they are asking? Okay, so to understand, we have one particular formula that RT is equal to R naught 1 plus alpha T. So again, ratio ತಗೊಂತೀನಿ. So RT2, you have to find, you have know that RT1 is equal to R naught 1 plus alpha T2 divided by R naught 1 plus alpha T1. So R naught and R naught get cancelled. What about RT2 by RT1? 2 divided by 1 is equal to, okay, 2 divided by 1. So 1 plus alpha T2 divided by 1 plus alpha T1. Okay. ಈಗ substitute ಮಾಡ್ತೇನೆ ನಾನು values 1 plus alpha T2 divided by 1 plus alpha into 300. So ಈಗ cross multiply ಮಾಡಿ ಆಗ 2 plus alpha 600 is equal to 1 plus alpha T2. Okay. So when I bring this one to the other side and this to the other side, so 2 minus 1 is equal to alpha T2 minus 600 into alpha. So alpha common ತೆಗಿತೀನಿ. Alpha into T2 minus 600. So ಇದನ್ನ ಮೇನ್ ಮಾಡ್ತೀನಿ. ಏನು ಮಾಡ್ಬೋದು ಅನ್ಸುತ್ತೆ. So 1 divided by alpha is equal to T2 minus 600. So 1 divided by 0 point, ಇಲ್ಲಿ ನೋಡಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿಲ್ಲಿ 0.00125 ಅಂದರೆ ಡೆಸಿಮಲ್ 1 2 3 4 5. ಸೊ ಶಿಫ್ಟ್ ಮಾಡಿದಾಗ ಏನಾಯ್ತು 125 into 10 to the power minus 5. ಆಮೇಲೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀನಿ 125 into 10 to the power minus 5 is equal to T2 minus 600. So 1 divided by 125 is to 1 divided by 125 is to, it is 0.008 into 10 to the power minus 5 ಇರೋದು plus 5 ಆಗುತ್ತೆ is equal to T2 minus 600. So when you do this, you'll be getting 800. So 800 is equal to T2 minus 600. So T2 is equal to 800 plus 600. So 14 ಆಗುತ್ತೆ. So 1400 Kelvin. That will be your answer. So option C is the correct answer. Okay. I hope you are clear with this. You don't have any doubt related to that. Okay. So we'll catch in the next class. Thank you all. Have a great day.